Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Adding and Subtracting Rational Expressions. In this, we're going to go ahead and we're going to start back with what you might have done when you were younger, because we're going to need that to be able to compare. So let's just take a quick look at 1/3 plus 1/5. Now I know probably have been doing this with a calculator the last few years. However, we're going to actually remember how to do it by hand. So you used to have to find the least common denominator as your first step. Well, the least common denominator is the least common multiple of 3 and 5. So least common denominator and least common multiple, basically take your denominators. That's what I did here. They're very much related. The only reason why we call it denominator here is because it's written in fraction form, whereas here, least common multiple, we've just listed the numbers. I just let you know that because a lot of math books will actually have you doing the least common denominator when it's written like this and ask you, hey, what is the least common denominator? Other times they might just give you some information and say, hey, what's the least common multiple? So those questions are very, very similar. Now, because 3 and because 5 are a prime number, many of you are just going to go, well, I'm going to times this by 3. And not by 3, by 5. And I'm going to multiply this by 3. And what we're doing there is we're unreducing each fraction. So 1/3 is equivalent to 5/15. And 1/5 is equivalent to 3/15. Now that we've unreduced them, and they now have the same denominator, well, think about it. If you have 5/15 of a pizza here, and you have 3/15 of a pizza here, when you put them together and slide them onto the same tray, don't we now have 8 of the 15 slices, or 8/15? And that's absolutely how we're going to do that. Okay? So, what happens if I were trying to do 1/20 minus 1/16? Now you may not be able to just go, oh, hey, just multiply the first one by the second one, the second one by the first one. I mean, we can do that, but we're going to have 320 as our denominator, and then we'd have to reduce. And with numerical factors, that's one thing, but when we get to algebraic factors, that would not be ideal. So I need to show you a way of finding your least common multiple of 20 and 16. So we're going to find a way to find the least common multiple of 20 and 16. Now, I understand many of you in elementary school might have done this. 20, 40, 60, 80, 100, 120, ... right? 16, 32, 48, 64, 80, 96, ... Hey, 80 was on the list. That would be the 1, 2, 3, 4. So I'm going to multiply both by 4. And 80 was on this list, and it's 1, 2, 3, 4, 5. Okay, that's great when we have numbers. I don't want to do it that way because we're not going to have numbers. We're going to have variables. So instead, I'm going to use Venn diagrams because it really helps me. So 20 is 4 times 5, and that's 2 times 2. Okay, so keep in mind that 20 is 2 times 2 times 5. 16 is 4 times 4, and each of those is 2 times 2. So 16 is 2 times 2 times 2 times 2. And now I'm going to make a Venn diagram. And some of you might be thinking, why the heck are you doing a Venn diagram to find this least common multiple? I get it. So take off a 2, put it in the middle. Take off another 2, put it in the middle. They both agree on those two 2's. 20 had an additional 5, and 16 had 2 more 2's. So if you look at the 20 circle, you'll see that it's 2 times 2 times 5. If you look at the 16 circle, you'll see it's 2 times 2 times 2 times 2. When we put all the circles together, 5 times 2 times 2 times 2 times 2 it equals 80. So also, hey, fun thing, in here is your greatest common factor. You just use the fewest sections. When you use the most sections, you get your least common multiple. So the Venn diagram actually gives you your greatest common factor of 4, because they both divide by 4, and it gives you your least common multiple, which is 80. Also, what's outside of the 16 circle? A 5. That's why we're multiplying top and bottom by 5. What's outside of the 20 circle? 4, because 2 times 2 is 4. That's why we're multiplying the 20 by 4. So that Venn diagram really helps us come over here and do this. It's really weird to do it that way. Probably not the way you did it in elementary. I get that, but I'm going somewhere with this. So please keep that in mind. So you have 4/80ths of a pizza or something here, minus 5/80ths. Uh-oh. We're taking away more than we have, so we're going in the hole. We are in the hole 1, negative 1/80th. So once you get a common denominator, you add and subtract your numerators. Alrighty, so what is this going to look like as an algebra problem? I'm going to start by giving this one with a common denominator already. That way we can focus on what we're doing. Okay, and just a quick note, because we always should take notice of this. X cannot be negative 1.5. The reason for that is 2x plus 3 cannot equal 0. So 2x cannot be negative 3. When you divide that, you get negative 1.5. So again, that common denominator cannot be 0. You only need that if the directions tell you to, but it's never a bad problem to do it. Okay, so common denominators, we're going to subtract. I find the subtracting fractions is when most sign errors happen to occur. So I'm going to rewrite this problem. We have a common denominator of 2x plus 3. And to simplify our numerator, we are going to be taking 10x plus 5 and subtracting 4x minus 8. That subtraction sign is going to distribute to that second quantity. So it's going to become minus 4x and positive 8. So we have to keep that in mind. So 10x plus 5 minus 4x plus 8, all with that common denominator of 2x plus 3. So when we combine like terms, we are going to get why did I write minus plus here? That's a minus. There we go. sorry about that error. That's the other error you have to watch for, is writing the problem down wrong. It happens a lot more than you would think. And 2x plus 3. Now, I do notice that my numerator has a GCF. Because it factors, we might be able to reduce this problem. So let me check. If I factor out a 3, that leaves me with a 2x plus 1 in the numerator and a 2x plus 3 in the denominator. These are not the same, so no, it does not reduce. Okay, so this is the proper answer, and we know that, and I don't care which way you write it, it can be written in either way. X cannot be negative 1.5. So we're done with the problem. But you notice that I did check for reducing. Again, fractions always must be answered in reduced form. So let's keep that in mind. Okay, so find the least common multiple of x plus 2 squared and x squared plus 5x plus 6. Okay, wow. Now, again, if I said find the least common multiple of 8 and 11, let's do 8 and 12. You would be like 8, 16, 24, 12, 24. Oh, you could make that list. We can't make that list here. Okay? We know 8 and 12 both divide by 4. 8 is 2 times 4. 12 is 4 times 3. And if I do 2 times 4 times 3, it equals 24. So again, that's that Venn diagram thing that we're going for. So x plus 2 squared is x plus 2, x plus 2. And if I factor this x squared plus 5x plus 6, I get x plus 2 times x plus 3. So make that Venn diagram. Their common factor is x plus 2. All right, the orange one is x plus 2 times x plus 2. The blue one was x plus 2 times x plus 3. And again, this is that blue circle, or oval, or whatever. Not the best circle, right? And this was the orange one. Okay, so now we have a Venn diagram made. Our least common multiple is going to be x plus 2 times x plus 2, so I'll write squared, times x plus 3. That was really messy. I did not even close my parenthesis. So I find a Venn diagram the hands down best way of identifying the least common multiple. Some of you might have been able to see it from the underline to the answer. You can think about that if you want. That is not my preferred method. Okay. So now I'm going to give you a adding problem. Two over x plus 2 quantity squared plus 5 over x squared plus, let's see, what did I want to do? 5x, yeah. If you'll notice, those denominators are the two things I just gave you to practice finding the LCM, right? So the orange circle was x plus 2 times x plus 2. remember that is x plus 2 times x plus 3. So our green, I didn't green this time, x plus 2, x plus 3. So that means our common denominator is going to be x plus 2 twice, x plus 3. Okay, I'm going to rewrite the original problem in factored form. Giving myself a little bit of space here. Okay, I have to multiply just like we did early, right? I'll go ahead and refresh your memory. We multiplied the numerator and denominator by something so that it unreduced. That's what we're doing again. Okay, so right now this circle has x plus 2 times x plus 2. What's outside the circle? X plus 3. So that's why I multiplied that. Okay, the green circle currently is x plus 2, x plus 3. What's outside the circle? X plus 2. So now they both have the same denominators. And you should be noting that x cannot be -2 or -3, but that's a little bit superfluous at this moment because we can do the problem without knowing that. It's always good to have, but that's not our big focus right now. So when I simplify this, I don't want to multiply out the denominator because it is a perfect factored form. Why can I not write my problems down correctly today? And I'm going to shorthand my denominator. So I can leave my denominator in that form because it is in a simplified factored form. However, I cannot leave my numerator in this form because it is not in a simplified factored form. And you might be saying, but there's parentheses. This plus sign right here separating them says, hey, you are not in a simplified factored form. So we still have to do some work to our numerator. Our denominator is great. We can stop there. But our numerator is not. So I'm going to distribute 2x plus 6 plus 5x plus 10. You can't see that. And we have that common denominator of x plus 2 squared, x plus 3. So now we can combine like terms. And we'll have 7x plus 16 over x plus 2 squared, x plus 3. And now that's as simplified as it can get. I can't factor because 7's prime. There are assumed parentheses around this. So the deal is, if you have parentheses in your numerator, it has to be in factored form. Here we had parentheses in the numerator, but it was not in factored form because of that plus sign. Here, the plus sign is fine because technically there aren't parentheses. So you either need it to get it where there's no parentheses or you need to get it into factored form. Again, there's assumed parentheses in this case, and we cannot factor it because 7x plus 16 is prime. And x cannot equal -2 or -3. That's our final answer. Okay, so I have a lot of students who like steps. So step 1, I would factor those denominators. Okay, step 2, that's when I'd really find my domain errors if the problem asks for it. 3, I would use a Venn diagram to find the least common multiple slash the least common denominator. And again, the least common multiple is the two denominators. It just depends on how it's worded. Least common multiple is just if they're asking you to find it. Least common denominator is it's in fraction form and you've got to do that. If you're actually adding and subtracting, go ahead and get a common denominator. Okay, and then after you do that, add or subtract your fractions. And finally, reduce if possible. Now remember, to reduce, you must factor that numerator. If you cannot factor your numerator, you cannot reduce. So make sure that you're taking care of that step as well. So if you're a step-by-step person, there we go. That's kind of what we're going to focus on. Factor those denominators. Check for domain errors. Use that Venn diagram. I'm using it because it's kind of hard to write a list like you did in whatever grade you first added fractions in. All right, so let's go ahead and do a couple more. And then I'm going to do a word problem kind of thing that, well, it usually confuses people, so we'll talk about that. All right. X plus 6 over x squared minus 4 plus 2 x squared minus 5x plus 6. Okay. So, do you remember what step 1 was? It was factor, right? So we got to factor those denominators. Why the denominators? Because that's what I'm using for least common multiple. So x squared minus 4 is x plus 2, x minus 2, x squared minus 5x is x minus 2, x minus 3. Right? Yes. This, when you change the signs, like if you have a minus 6 instead of a plus 6, it really makes you double check your factoring because the factors are very similar. Okay, Venn diagram. Some of you might already be seeing it. They have this x minus 2 in common. The orange circle also has an x plus 2. The blue circle also has an x minus 3. So there's our common denominator. So x plus 6 is currently over x plus 2, x minus 2. And 2 is currently over x minus 2, x minus 3. All right, what is missing from our orange circle? That's that x minus 3. What is missing from our blue circle? That's that x plus 2. Now they have a common denominator. Okay, so I have x plus 6, x minus 3, plus 2, x plus 2, because I'm adding them together, right? With that common denominator of x plus 2, x minus 2, x minus 3. Okay, so we factored the denominators. We didn't write down our domain errors yet. We did skip that step, -2, 2, and 3. And now we've added and subtracted our fractions. But, again, the numerator either has to be in perfect factored form or no parentheses at all. The denominator is in perfect factored form. And the numerator is not because of this plus sign. Okay, so either no parentheses or perfect factored form. And that holds true for both the numerator and the denominator. The denominator is there because this is written as a product. The numerator is not. So now we get to multiply a lot of stuff. X squared minus 3x plus 6x minus 18. So I FOILed that out. Plus 2x plus 4 all over x plus 2, x minus 2, x minus 3. Great, there's no parentheses in the numerator, but it's not simplified. I mean, we always simplify stuff. So we're going to combine like terms. And I'm just changing colors as we go so you can see each line separately. Negative 3x plus 6x is 3x, plus 2 more x is plus 5. Negative 18 plus 4 is negative 14. We have a common denominator, x plus 2, x minus 2, x minus 3. Okay, our last step said reduce as possible. So right now, I've satisfied the no parentheses and simplified. I should say no parentheses and simplified. And I have the bottom in perfect factored form, so that's great. But I need to check, does it reduce? Okay, so in order to find out if it reduces, I'm going to factor the numerator, so it's in perfect factored form. Multiply to negative 14 and add to 5, that'd be 7 and negative 2. It does indeed reduce. Now taking that out does not take away the domain error. The domain error is still going to stand. So our final best answer would be x plus 7, x plus 2, x minus 3, comma, or semicolon. X cannot be negative 2, positive 2, or 3. So we keep the 3 domain errors even though we've reduced. Now, some individuals would like you to go ahead and FOIL this out. Why? I find that a wasted extra step. I would be happy here, and this is a very acceptable answer. Okay, let's just do some more problems just because. This one I'm going to kind of shorthand and make it look like I would make it look if I were doing it, because I know some people are probably not happy with all the steps that I have listed and how much room it takes up on their paper. Okay, so first thing I'm going to note is x cannot be negative 4/3 and it cannot be 1/2, and I got that by setting this and this equal to 0. The second thing I'm noticing is, hey, it's already in factored form, so I'm just going to go, hey, 2x minus 1 to the bottom, 2x minus 1 to the top. By putting that here, now this matches that. And then I'm just going to go straight to multiplying. 4x squared minus 2x. Now I'm remembering to distribute this negative through. Minus 4x squared plus 11x plus 12 with my common denominator. Okay. Then I'm going to simplify like terms. I notice the x squared cancels out the x squared. I'm left with 9x plus 12. 9 and 12 both divide by 3. So I have a GCF of 3. So this does reduce. So my final answer would be 3 over 2x minus 1, semicolon, x cannot be negative 4/3 or positive 1/2. So there I kind of fit it all into one window instead of having a lot of lines vertically. So I know some individuals are happier that way. Also, I kind of said, oh, what does this one have that this one doesn't? Five over 3x plus 1 over 6x squared minus 1 over 3. Okay, so I find that students on this one end up doing too much for their common denominator. And this one has 3 parts, so you may not want to do a Venn diagram. So I'm going to go ahead and write the multiply in parentheses. This is 3 times x. This is 2 times 3 times x, and this is just 3. So they all have a 3. But this one is also being multiplied by 2. Notice how I put that in pink. So times 2 times 2 times 2 times 2. I'm going to put blue. So here's a blue x, here's a blue x, but this one didn't have an x at all, so I'm going to put a blue x in the bottom and a blue x on top. Now, this one also had an orange x. So I'm going to put this one in orange, top and bottom, and this one in orange, top and bottom. So I did as little as possible. I find some people try to multiply this one by x squared and this one by x, and then they wind up with x cubed. Do not go over your highest power. Do not go over your highest power. If you're doing that, you're doing way too much. So our first one is 10x. Our second one is just 1. And our third one is 2x squared. And our common denominator is 6x squared. So when I do that, I'm going to write negative 1 just in case, times 2x squared minus 10x minus 1. I like having a positive lead coefficient, so I like factoring out the negative 1. Let's see, will this factor? It multiplies to 2 and adds to negative 10. Nope, that one's prime. So I can just write it as and x cannot be 0 in this case. That's the only domain error. So do not go over your highest exponent. Okay, keep things simple. Okay, now okay. Let's say student run A can run a race in X minutes. Okay. Student B can run the same race in, wow, I put that really close, X minus 2 minutes. How much faster? is student B. And you see these a lot in the, like if a person can paint something, a building in 5 hours, and another person can do it in X hours, how fast are they, how long would it take together? It's kind of the same idea. So how much faster? Well, let's think. Now, we know time, right? Rate times time equals distance. Okay. And so your rate is your distance divided by your time. So hypothetically, let's say this is a 1 mile race, just one to make it easy. Okay, and student A finished it in 10 minutes. So that means student B would have done the 1 mile in 8 minutes, right? Well, faster is comparing like 60 miles per hour versus 32 miles per hour, right? Here, this is 28 miles per hour faster. So we're comparing rates. So here we'd have to do distance divided by time, and here we'd have to do distance divided by time. And obviously this is the faster person, so we would do the fast person minus the slow person. Then you get a common denominator, 40, right? So times 5, 5 40ths minus 4 40ths, 1 40th faster if it were a 1 mile race and we're talking 10 minutes and 8 minutes, but they didn't tell us the miles. And we don't know the times. But we still are going to do it the same way. So student A has a distance of 1 race in X minutes. And student B has 1 race in X minus 2 minutes. So to find out how much faster, we're going to take the fast student minus the slower student. Again, fast and slow is relative. I don't know if they're good racers. We're just answering the problem. Now we see something we can do. You cannot minus 2. You have to multiply by a factor. So this is missing a times x. This is missing a times x minus 2. Now they have the same factor for the denominator. And we'll get the numerator of x minus x plus 2 over our common denominator of x, x minus 2. And I got that because I distributed the -1. And of course, x cannot be 0, which makes sense. You can't run a race in 0 minutes. X cannot also not be 2, because if 2 minutes, this one would finish it in 0 minutes. Neither racer can run 0 minutes and finish a race. So the race has to be actually more than 2 minutes, because anything less and racer 1 wouldn't be running at all. All right, combine like terms. 2 over x times x minus 2. So once we find the number of minutes that runner 1 finishes it in, then we know how much faster they are compared to each other. Okay, now the complicated problems. I actually really like these. We're going to do a simple one, and then we're going to do one with algebra. You might have seen a problem. I actually really like these because I can do them mentally. Of 1/3 plus 1/4 divided by 1, actually let's go with 2/5 minus 1/6. And you might be going, oh my goodness. All right, well, first of all, 1/3 plus 1/4. Okay, they have a common denominator of 12. So 4 12s plus 3 12s. 5 and 6 have a common denominator of 30. So 12 over 30 minus 5 over 30. Okay, then we'll have 7 12s divided by 7 30ths. Okay, keep, switch, flip. 7 cancels 7, and I have 30 over 12. Then those both divide by 6, and I have 5 over 2. Okay, great. That's a lot of work. I don't like doing it that way. I like saying 3, 4, 5, and 6 all go into 60. So I'm going to multiply the numerator by 60, and I'm going to multiply the denominator by 60. A third of 60 is 20. A fourth of 60 is 15. 2/5 of 60, well, 1/5 is 12, so 2/5 is 24. Minus a sixth of 60, that's 10. 20 plus 15 is 35. 24 minus 10 is 14. If I divide them both by 7, I get 5 and 2. I multiplied by the least common denominator of all 4 fractions. And then I distributed it to the numerator, and I distributed it to the denominator. So much less work. Because once I do that distribution, I have, instead of a fraction inside of a fraction, I just have integers and integers. So I'm going to use that for other kinds of problems. One over A minus 1 over B divided by 1 over A plus 1 over B. So my common denominator for all of them, because some have an A and a B, is AB. So I'm going to multiply everything by AB. And I'm going to write this out the long way the first time, and then I'm going to show you the same problem shorthand. Now remember, when you're multiplying fractions, you're multiplying it. I got to make it a fraction by putting it over 1. So when I distribute this AB to this 1 over A, I'm getting 1 over A with basically an A being multiplied into the top and a 1 being multiplied into the bottom. Do I really have to have times 1? No. Minus 1 over B. So when I distribute this AB to that, I'll have 1 AB in my numerator over 1 over A. We have to distribute that AB. Plus 1 over B, and I have to distribute that AB. So simply put, I multiplied every single fraction by AB. That's all I did. Did I treat them all fairly? Yes, I distributed it to my numerator. I distributed it to my denominator. Why did it only go in the tops? Because technically it's over 1. Now, fraction-wise, the A's cancel, and I'm left with B. The B's cancel, and I'm left with minus A. The A's cancel, and I'm left with B b's cancel, and I'm left with a. And that's a simple binomial on the numerator with no factors. That's a simple binomial on the denominator with no factors. That's the answer. Now, a cannot be 0 because of right here. B cannot be 0 because of right there. And a plus b cannot be 0. So, because of that denominator. You could also write this as a cannot equal negative b. See how I just subtracted it to the other side? I don't care which way you write it, but that's your note. That's your final answer. So how would I have done this if I were just doing it on my own? I'm going to rewrite it over here. 1 over a minus 1 over b. Well, I'm just going to come in here and write ab, 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 cancel, 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 cancel. B minus a over a plus b. That's a lot better than doing what I did here the first time where I got common denominators and then added them, and then I did the keep switch flip, because if had I done that, I would have had I'm not going to rewrite it all. I'm just going to come on, factor, focus. B minus a over ab divided by b plus a over ab. Keep, switch to multiplying because technically this is a big divide sign. Focus. There we go. So times the reciprocal. Cancel, cancel. And I know I commuted that to a plus b. B minus a and a, or a plus b and a, b plus a are the same thing. So when you see a fraction written like this is the same as writing this fraction divided by that fraction. So just because it looks yucky, it's fine. All right, we're going to do one more. One over x minus 1 divided by x plus 1 over 3 plus 4 over x minus 1. Now, you could do a lot of work on this. However, I'm going to make it look worse before I make it look better. Okay. First thing, I'm going to multiply everything by x minus 1. I'm distributing it. That took care of that. But I still have a, I call them a mini denominator. So I have a denominator inside the denominator. So now I'm going to multiply everything by 3. That cancels this 3. Now, what I have left in the numerator is 3 times 1. What I have left in the denominator is x plus 1, x minus 1, plus 3 times 4. So while this looked not fun, and then when I switched it up and rewrote it, it looked really not fun, that doesn't look bad to me. 3 times 1 is 3. Let's FOIL that out because the denominator is not simplified. X squared plus x minus 1 plus 12. 3 over x squared plus 11. Boom, done. You could have gotten the common denominator and added these together, then keep, switch, flip. You would have gotten to the same answer. So it's just a way of making things quick. Again, x could not be 1. because of this right here and right here. And x squared plus 11 is always positive. Any number squared is a positive, and you add 11, you're still at a positive, so it's not going to hit 0. All right, so a couple different approaches. You can go back, watch them, try some on your own, using both approaches, and pick the one that you like best.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.